So to do this, we're going to need some principles of equality here. Just principles of equality says whatever you do to one side, you got to do the other side, okay? Now, we know from the past that addition and subtraction, we use those two principles of equality if we see addition and subtraction with the variable we're solving for, but we do this to make make zeros, okay? Now, why are we making these values zeros? It's because if we can make them zeros, we get to ignore them. Kind of like people that are zeros, you know what I'm saying? We just ignore them. So the other ones we have are multiplication and division, like this. That is usually to make the coefficient, or sometimes coefficients, in this case for today's lesson, ones. We make ones with this, right? Now, usually, in fact, to make ones, we usually just use division, but multiplication happens from time to time. From what I remember, I don't remember seeing any distribution or, well, there probably is going to be some combining like terms. But also, we now have to consider some factoring involved to sometimes yank out the variable that we're solving for, and so we can isolate it, okay? So principles of equality really are meant to isolate the variable and then to get that coefficient to be a 1. So isolating is usually with addition and subtraction, but we can use multiplication or division for isolation as well. And then, of course, factoring, yeah. This says, we got two A's in this, by the way. We got a large A, uppercase A, and a lowercase a. It's solving for the lowercase a. Now it says solve A equals 1/2 H times A plus B. I believe that's the formula for a trapezoid, the area of a trapezoid, if you care. But it's A, right? That means in the end, we need the equation to read A equals something. In fact, I'm going to reverse that and make it A equals something. Why am I putting A on this side of the equal sign? Because it's on this side of the equal sign. And I think I can deal with that, okay? So to start us off here, what I would like to do to isolate this A is I don't want this garbage right here. Now, some students are like, I need to distribute that stuff, don't I? You could. I just don't want to, so I'm not going to, okay? So, but I'm going to make a 1. I'm going to make two 1s, but one at a time. So first off, right, principles of equality, whatever I do to one side, I got to do to the other side. The 1/2, I'm going to multiply by 2, but if I do it to one side, I got to do the other side. That's kind of sloppy, but it's best I can do. So that is now on the left, I got 2A equals, and here's the 1, right? You got 2 divided by 2 is 1, and then we got the rest of that, which is H times the binomial. So that's the first one. The second one is where I'm going to take the H and make it a 1. So I'm going to divide the H. Well, I'm going to show the division a little different, actually. H, I'm going to divide it by H. But if I do it to one side, I got to do the other side. So on the left now, I have 2A over H, which is going to equal, well, that became a phantom 1. And even though the A plus B is in parentheses, I don't really want it in parentheses anymore. So I'm not going to use the parentheses. I don't see anything that can be distributed or factored out there. Now, we're pretty close. Okay, we're pretty close to getting A. I just don't want the plus B right there. Garbage, right? So last thing I got to do now is get rid of that B. And I'll do that by subtracting B. Now over here, I'm kind of putting it on the right just because I feel better that way. But on the left side, I've got the 2A over H term. And then that was minus B. Sorry that B looks like a 6. But we did zero out the B, and then we're just left with the A, which has been dropped. That's what we wanted. We just wanted it to be A equals some garbage. It looks like garbage, but we got to get used to looking like this right now for this lesson, okay? Because we're used to seeing just A equals maybe some number, maybe two numbers, but now it just equals some kind of looking expression, I guess. This equation that we started out with, it's the same exact equation right here, just written differently, that's all. And by the way, some of you guys are like, I want to just make that common denominator. So another way you can do this is 2A minus BH all over H equals A, and that's the same thing. I don't really care how that happens, but some students know how to do it. I just recommend stopping right there because it's less work than to make this common denominator stuff.